Have you ever melted an ice cube, boiled water for tea, or watched a fog machine create a spooky mist? These everyday experiences are all about matter changing its form, but have you ever wondered how scientists precisely categorize these transformations? Science categorizes different matter phases primarily by the energy of their particles and the forces acting between them. The most familiar phases are solid, liquid, gas, and plasma, each defined by distinct physical properties related to how their constituent particles are arranged and move. This classification helps us understand and predict how substances will behave under various conditions, which is incredibly useful for everything from engineering to astrophysics. The fundamental reason for these categories lies in the balance between kinetic energy, which causes particles to move, and intermolecular forces, which try to hold them together. In a solid, particles have low kinetic energy, meaning they vibrate in fixed positions because the attractive forces are very strong. As you add energy, usually as heat, particles gain enough kinetic energy to overcome some of these forces, allowing them to slide past each other as a liquid. Add even more energy, and they can completely break free, moving randomly and independently as a gas. The ultimate step is plasma, where so much energy is added that electrons are stripped from atoms, creating an ionized gas with unique electromagnetic properties. To observe and understand these phases, consider how external factors influence them. Pressure and temperature are key controls. Increasing temperature typically adds energy, favoring transitions from solid to liquid to gas. However, increasing pressure can force particles closer together, effectively enhancing attractive forces and sometimes causing a gas to condense into a liquid or even a solid, even without significant cooling. Think about a pressure cooker. It increases the boiling point of water by holding the steam under higher pressure. Beyond the common four, physicists continue to discover and categorize exotic states of matter, each with its own unique behavior. For example, Bose-Einstein condensates from at temperatures just above absolute zero, where atoms lose their individual identity and behave as a single quantum wave. Another fascinating state is a supercritical fluid, which exists at temperatures and pressures above a substance's critical point, blurring the distinction between a liquid and a gas. These states demonstrate the vast range of possibilities when matter is pushed to its energetic limits. Ultimately, science categorizes matter phases to provide a coherent framework for understanding the universe around us. By knowing the energy state of particles and the forces at play, we can predict a substance's behavior, design new materials, and even explore the extreme conditions found in stars or exotic lab environments. It helps us appreciate that the matter we touch every day is just one small part of a much larger, more dynamic story.